Hello everyone, my name is Afan, and today we're going to do some graphing. So what we're going to do today is we're going to look at the graph of tangent x. So if you've done trigonometry or some basic trigonometry, we know the graphs of sine and cosine, right? So if I had a graph like this, sine is a wave, so is cosine, just cosine is a little bit shifted. So we haven't taken a look at tangent x, or maybe you have. In that case you wouldn't be here, but you still are. But we're going to take a look at tangent x. So here I have a horribly drawn graph, or a basis of a graph. I apologize. I try drawing straight, but my hand is not capable of doing that. And most of my friends and family know that. But okay, apart from me, let's go ahead and let's take a look at the graph of tangent x, alright? So what I'm going to do is I'm not going to plug in values of tangent x to make this graph. You could do that, that's totally a viable option, but it would take you quite some time to make a table of values with all that tangent. So what we're going to do is we're going to use this instead. So tangent, as we know, is just sine over cosine, right? We can all agree with that, that isn't anything new. So what we're going to do is we're going to use this property, that tangent is sine over cosine, and use that property to graph the graph of tangent. Alright, so let's start at 0, alright? I don't know what happened with that 0 there. I'm going to use a different color to graph, alright? And I also have another color because what you're going to notice is we're going to have some asymptotes. We'll get there. Alright, so let's look at tan of 0. So tan of 0 technically is just f of x, or f of 0 is what we're doing, is sine of 0 over cosine of 0, right? That's the same thing as tan of 0. So sine of 0, as we know, if you take a look back at your old graph, sine of 0 is simply 0. And if you remember what cosine of 0 was, that's 1. So what is 0 over 1? Well, that's just 0, right? Because we're not dividing by 0. 0 is just being divided. So 0. So we know there's going to be 1 point. So f of 0 is simply 0. Alright, we know 1 point. And as we know with our graphs, right, of as we know with graphs of our trigonometric ratios, we go up by 90, 180, 270, 360, like that, right? So that's how I have my graph set up. So we did one significant point at 0, so we know at tan of 0, it's 0. So let's try tan of 90 degrees. So pi over 2, I'm just using radians. Tan of 90 degrees. I'm going to switch back and forth, so if that bothers you, I apologize. Okay, so let's do tan of 90. Notice that something's going to happen. Some of you that are already familiar with this will know what's going to happen. So, well, look, I used my red marker on the black, and now it's... Okay, so f of 90, alright? So sine of 90 over cosine of 90. Great. So if you know what sine of 90 degrees is, you know that's 1, so that's not a problem. But what's cosine of 90? Cosine of 90 is actually 0. Okay, now that's a problem. 1 divided by 0. And as we know, 1 divided by 0, you can't do that, the world breaks. So let's not break the world right now, the world is broken as it is right now. Okay, so at 90 degrees, it's 1 over 0. So what that means is that that point doesn't exist. What happens is that at that point, there's actually an asymptote. So at pi over 2, there's actually an asymptote. So there's an asymptote at pi over 2, so at 90 degrees. Okay, so there's an asymptote there because sine of 90 is 1, cosine of 90 is 0. So again, you see why there's an asymptote, right? Because this point is literally not possible. So what happens to this entire part of the graph? What's happening there? Well, what we can do is, it's a little bit of calculus terminology, we can basically see the limit. What happens as we go there? Alright, well the limit doesn't exist here, but let's see what happens as we get there. And actually that was bad, the limit does exist here, but don't worry about that. So if sine of 90 doesn't work and cosine of 90 doesn't work, well let's try and get close to 90 as possible. Let's get as close to 90 as possible, alright? So let me erase this. Okay, so let's do f of 89.99999, alright? That should be possible. So f of 89.999. Alright, well that's simply sine of 89.999 divided by cosine of 89.999, right? So we can try and get as close to this as possible. What you'll notice is this is going to be a huge number. So a big number. This is going to be a huge, huge number. So all this means is that as we approach pi over 2, as we approach 90, the value of the function is going to skyrocket. It's literally going to infinity. And I'm not using the word infinity as a joke here. It's literally going to go to infinity as we get close to pi over 2. So what the graph is going to look like in this quadrant is it's going to go like that. Alright? That's how it's going to look like. It's just going to go right up, because it's never going to touch this point here, but it's going to get as close as possible to it. And now, one thing I will say is graphs of tangent are symmetrical. So, pi over 2, if we know there was a asymptote there, 90 degrees, guess what? At negative 90 degrees, as you know with sine and cosine, there's going to be an asymptote there as well. So let's go ahead and draw that. Right? Let me draw that. Okay, so if the positive region here, it went to positive infinity, what's going to happen here in this little region is that the graph is literally going to go to negative infinity. The value of the graph. So what this is going to look like is like this. There you go. And there, right there, is one point. So at 0, there's a point, but as we get close to pi over 2, as we get to 90 degrees, tan of 90, not possible, so we go to positive infinity. When we get to negative 90 degrees, or pi over 2, we go to negative infinity. So this is what the graph looks like. Alright, so let's draw a little bit more of the tangent graph, using what we have so far. But now, we know that this is the general shape of the tangent function. Now, literally, it just repeats. So let's go to pi, okay? Pi is 180 degrees. So let's do f of 180, alright? So equals sine of 180 over cosine of 180, alright? So cosine of 180, as we know, is 1, and sine of 180, if you think back, is simply 0. Okay, so we have 0 again. Alright? Good. So now that we have that, okay, yes, alright, that's correct. There's a point there, and at 3 pi over 2, if you remember, 270 degrees, 3 pi over 2, there's going to be the same case that happened here. What's going to happen is that there's going to be an asymptote. So, let's go ahead and draw that. There we go. And basically what the graph looks like is this again. You have that, and over here, you have it going to negative infinity. So this pattern that you see here basically repeats every single time. So the graph of tangent, again, this is how we come up with the graph of tangent. So at every point where sine is 0, so at sine of 0, it's 0, sine of 180, it's at 0, sine of 360, it's at 0. So basically what's going to happen is that at every single 0 for sine, we're going to have a point on the tangent graph. But whenever cosine is 0, so we know cosine is 0 at pi over 2, 3 pi over 2, 270, 90 degrees. At those points there's an asymptote. Because again, we're going to be dividing by 0 and that just doesn't work, alright? So this is the general graph of the tangent function. So you'll have your asymptotes, and then you'll have the graph going to positive infinity, and the graph going to negative infinity. If you can draw this little bit right here, this section right here, you can draw literally any other section, because this is the most important section. It gives us the symmetry, it gives us a basic image of how the graph looks. This I drew here just for another representation, but this is the important part, negative pi over 2 to pi over 2. If you can understand this part, you'll know basically what's happening. And you might be wondering, well, where are the asymptotes coming from again? Well, again, it's coming from this property right here, sine over x, sine x over cosine of x. So this is how we make the graph of the tangent function. Hopefully this video taught you a little bit about the tangent function and why it looks so weird and why it does the things it does. Well, and it's really not that hard, just because we can use the sine over cosine. So hopefully this video helped, and please subscribe if these videos teach you something, and if you just enjoy watching these videos in general, it helps the channel. That's all for today, and I hope you have a great day.